1-1 part 2. Now I'm going to do applications of the linear variables. So I'm going to apply this to solving financial problems, uniform motion, work, mixture problems, different types of problems. A few formulas you need to know is I, which is interest, is equal to PRT. P is your principal, R is your rate, and so if you have a rate of 3%, you'll write it as 0.03, and time is the amount of time that you would be borrowing the money for. And also, D is equal to RT. Your distance is equal to rate times time. Be very careful when you're using them. Use labels to make sure that things cancel out nicely, because sometimes when you have a rate like miles per hour, but you have a time in minutes, you can't do that. You need it all to be hours or all of it to be minutes. So you need to convert, okay? And also, remember 5% is 0.05 or 5 over 100. So if you don't have a calculator doing some of the problems, if you put it as a fraction, it might be easier to solve. First example in the applications, the manager at a wholesale outlet earns $450 more per month than the assistant manager. If their combined salary is $3,700 per month, what is the monthly salary of each? So it says the manager's pay is $450 more than the assistant manager. So manager's pay is the assistant manager plus $450. Okay? So read the words and see what you can do. So we're going to say, let the monthly pay for the assistant manager, we're just going to call it the variable X. If that is X, then the manager's pay would be X plus 450. And the combined salary is $3,700 per month. So if I take the assistant managers plus the managers, that'll equal $3,700. Here's my equation, let's solve it. 2x plus 450 is equal to 3,700. Subtract 450 from each side, and you get 2x is equal to 3,250. Divide by 2, you get 1,625 for x. So the monthly pay for the assistant manager is X, which is $1,625. The monthly pay for the manager is X plus 450, or $1,625 plus 450, which is $2,075. Kevin won $735,000 on a TV game show. He decided to keep a certain amount for himself, give 1/2 of the amount he kept for himself to his daughter, and 1/4 of the amount he kept to his dad. How much did each person get? I'm going to say that he kept X. So when you read it, he gave 1/2 of the amount he kept for himself to his daughter. So 1/2 X went to his daughter, and his dad got 1/4 of the amount that he got, 1/4 of X. So that's all the money altogether. So if I add all these up, it'll equal the total amount. So if I add them all up, they'll equal the total amount. So let's solve that. 735,000 is equal to, and this is 1/4, this is 2/4, this is 4/4. 4/4 plus 2/4 plus 1/4 is 7/4. So 735,000 is equal to 7/4 X. Multiply the top and bottom, 4 over 7, 4 over 7. That way you'll get X. And the easiest way to do this without a calculator is 7 goes into 735,000, it goes in ones, 0, 5. So you could cancel it out and then multiply by 4. That's probably the easiest way to do it. So 105,000 multiplied by 4 is 420,000. So he kept 420,000, he kept X. Half of X went to his daughter, so half of 420,000, which is 210,000. And his dad got 1/4 of that, which is 105,000. If you add these three up, they better equal 735,000. Mr. Mustafa received an inheritance of $7,000. He put part in a tax shelter paying 9% and part in the bank paying 6%. If his annual interest totals $540, how much was invested at each rate? So the amount invested at the 9% in the tax shelter, so when you read it, he put in part in the tax shelter. So let's say that he put in X, because I don't know, it doesn't tell what amount, but he put in X. But it does say that he had $7,000 investing altogether in both of them. So if he invested X in the tax shelter, then 7,000 minus X is what he invested in the bank. And if you add these two together, they better equal the 7,000, and they do. Okay? So now I have that written down. Now let's figure out an equation. He put part in the tax shelter and part in the bank, and they gave the interest rates. And they also told you your annual interest. So there's my annual interest. So that interest is equal to the interest from the tax shelter plus the interest from the bank. And the interest from the tax shelter is 9% of what you invested. And you invested X, so 9% of X. And he had 6% for the bank, and there's what he invested in the bank, so 6% of that is what he got from interest from the bank. So there's your equation. Solve it. So 9% X, if you distribute, 6 times 7 is 42, you know that, so let's move this over. That goes over two places, that you're really doing 70 times 6, which is 420. 6% X is 540. Combine your like terms. So 9% and 6 minus 6% is your 3%. 540 minus 420 is 120. And if it's easier for you, write this as 3 over 100. And you might be able to do the math easier. Okay? Because if you wrote this as 3, that's, and you had to solve it, there. Divide by 3 is 40. 40 times 100 is 4,000. So X is 4,000. So 4,000 went into the tax shelter. 7,000 minus 4,000, which is 3,000, went into the bank. And you're done. Next one, a car leaves New Orleans traveling 50 miles per hour. An hour later, the second car leaves New Orleans following the first car traveling 70 miles per hour. How long it will take for the second car to overtake the first car. So I did a table here. Let's organize the data first. It says the rate of the first car, the rate of the second car. So 50 kilometers per hour. And this rate, remember, I have it in kilometers per hour. Okay? You can say that one car travels X amount of time, the other one will travel X plus 1. This isn't the only way you could do it. You could call the first car X and then the second car X minus 1. It still works out. But the first car was on the road an hour earlier. So that's why the time that this is on the road is 1 hour more. Okay? And like I said, you could have said this is X and then this would be X minus 1. It's on an hour less. Rate times time is equal to distance. Rate times time is equal to distance. Rate times time is equal to distance. So there I have a table filled out. Okay? But now let's figure, what do we know? How long will it take the second car to overtake the first car? So that means how long will it take until they travel the same distance? If these are equal. So that's your equation. And that's what I did this here. There's your equation. When will they equal each other? And that's your equation you want to solve. So distribute your 50. Move your x's to one side and divide, and you have 2.5. So the second car will overtake the first car in 2.5 hours. Okay. X is 2.5. So the first car was on the road 3.5 hours. The second car was on the road 2.5 hours. Example 5. A goldsmith has 120 grams of gold alloy, and that's a mixture of gold and one or more other metals containing 75% pure gold. How much pure gold must be added to this alloy to obtain an alloy that is 80% pure gold? So I'm just going to say, let X be the amount of gold added. So the amount of gold in the new alloy is equal to grams of gold in the original plus the amount added. And that's in words what it says there. But let's put it in to an equation. And the amount of gold in the new alloy, I have 120 grams that I started with, and I'm adding X amount, and it's going to be an 80% mixture. So here's the quantity that I have, and it's going to be an 80% mixture. The original, I have 120 grams of 75%, and I'm going to add X grams of 100%. And if you want to be consistent, you could do this. There's 100%. Okay? So I have X grams of 100% gold. I have 120 grams of 0.75 gold, and I'll end up with 120 plus X grams of 80%. There's your equation that you need to solve. So I have 0.8 times 120 plus X is equal to 75% of 120 is 90, and then this is just X. 80% of 120 is 96, so 96 plus 0.8X is equal to 90 plus X. Move the 90 to the left, move the 0.8 to the right, and if it helps you, you could write that instead as 2 over 10 or 1 over 5. It should help you with the math to figure out that it's 30. So we need to add 30 grams of pure gold. Okay? And the last example that I want to do, an old pump can drain a pool in 6 hours working alone. A new pump can drain a pool in 4 hours working alone. How long will it take both pumps to empty the pool working together? So in 1 hour, the old pump empties 1/6 of the pool. The new pump would empty 1/4 of the pool in an hour. And I want you to just think about what that's saying. In 6 hours working alone, you can empty a pool. So in an hour, you'll empty 1/6 of the pool with the old pump. In 4 hours, you can drain a pool with a new pump. So in 1 hour, 1/4 of the pool would be emptied. So in terms of X, number of hours, the pump empties X over 6 and X over 4. Okay? So now my equation then, when I'm looking at it, I know if I have X hours over 6 plus how many hours it takes over 4, it'll equal 1 whole pool. So working together, I can empty 1 whole pool. And it's going to work X hours. And there's my equation I need to solve. Okay? Because if it worked 1 hour, you would do 1/6 and 1/4. If you'd add those together, that's how much of the pool would be emptied. So my equation, solve it. I would multiply by your least common denominator of 12. to get rid of the fractions. When you distribute the 12, you have 2x plus 3x is equal to 12. 2x plus 3x is 5x. Divide by 5. So that's 2 2/5 hours. Or 2/5 of an hour changing to minutes is 2 hours and 24 minutes. Because the 2/5 hours, if you multiply it by 60 minutes over 1 hour, the hour cancels out, and you'll have 24 minutes. So 2 hours and 24 minutes.